We're going to begin with this class opener, which is just a review of stuff that we already know. So in order to really understand simplifying radicals, you need to know the key concept that the square root of a times b, it could be written as the square root of a times the square root of b. Or you could work it backwards. In other words, if you had the square root of something times the square root of something else, you could put them together underneath one square root. That might help you. Okay. Here's another important fact about simplifying radicals. You can multiply the numbers that are out in the front with the numbers out in the front. You can multiply the radicals with the radicals. Okay. So let's just jump right into number 1, 40. 40 is not a perfect square number. So 4 times 10. Exactly. If you had 49, that would be a perfect square number, but it's not 49, it's 40. So you can't do the square root of 40. So you're going to rewrite it with multiplication to get a perfect square number. And we said 4 times 10 is the good combo to rewrite it as, because 4 is a perfect square number. So instead of the square root of 40, I have the square root of 4 times 10, and I'm going to split the root to each of them, right? It's really going to be the square root of 4 and the square root of 10, which, yes, it becomes 2 square root of 10, and that's your final answer right there, 2 square root of 10. 2 on the outside, square root of 10 on the inside. By the way, if you're confused with this, on the rest of this video after this class opener, I'm going to show you an alternative method known as the factor tree or prime factorization. I'll show you a different way of simplifying the square root of 40. But I really do prefer this method where you don't have a perfect square number, you rewrite it with multiplication to get a perfect square number. Okay, so one other fact that we needed to know was that the square root of anything could be rewritten as the power of 1/2, right? So we needed to know this, that the square root could really be rewritten as the power of 1/2. Now, what does that mean? That kind of means that you're going to be dividing the inside exponent by 2. Okay, so what's the answer going to be? It's going to be x to the 4th. Okay. Now, the explanation is that you could rewrite this square root, you could rewrite it as the power of 1/2. And on the inside, of course, you have the x to the 8th. So right here you have a power to a power, so you have to multiply. So 8 times half is what you guys said, x to the 4th. So your final answer is x to the 4th. You don't even need to show this work. It's this simple. When you take the square root of something that has a power, it's really just like dividing that power by 2. Now sometimes it doesn't work out that great. Like let's say the answer is just x to the 4th. The answer is just x to the 4th. Okay. But like I was saying, sometimes it doesn't work out that great. Let me show you an example. So if we move this to the side, like if I had the square root of x to the 7th, for example. See right there, 7 divided by 2, you don't get a nice answer, right? So what do we normally do when we don't have something that we want inside the square root? What we do is we rewrite with multiplication to get something that we want. So if we want something that's divisible by 2, we might as well rewrite the x to the 7th. We might as well rewrite it as x to the 6th times another x times x to the 1, right? And now we have that even power that when we split it, we could actually just divide by 2. So the square root of x to the 7th, your final answer is going to be what? X to the 3, and that's on the outside, and the square root of x is still on the inside. Okay? So what essential key component do we need to know to be able to do this? We need to know that the square root could be rewritten as a power of halves, and you want it to be divisible by 2. So if it's odd, go ahead and write it as the even number before it plus one more right there. That way when you split it, you could actually do this one, and this one just stays. Okay? Let's go back to the other questions here. Number 3. I did mention at the beginning of this video that, and yesterday and the day before yesterday, that when you have numbers and radicals, you can multiply the numbers with the numbers and the radicals with the radicals, right? So the number 2 out here, there's nothing else to multiply it with, so that's going to technically be a part of our answer right now. And the 3 and 15 that are inside the radicals, I'm going to put those together inside one radical. So I'm actually going to multiply 3 times 15. What do I get? 45. And the reason why I multiplied them together is because I can't really simplify a square root of 3. I can't really simplify a square root of 15. Even if I tried 5 and 3, it doesn't work, right? Okay. So 3 times 15 is 45. Now, the question is, could we simplify 45 now? Yeah. What perfect square number could I throw in there? Like 9 times 5. Exactly. 9 is a perfect square number. So let me rewrite what I have. I have a 2 on the outside, and instead of 45, I'm going to have a 9 times 5. I'm splitting the root. So the square root of 9 is 3, and I have a times 2 in front, and I have the square root of 5 at the end. So my final answer is 6 square roots of 5. 6 square root of 5.
Where did you get the 3 from again?
I got the 3 from actually doing the square root of 9. See, that was the whole purpose of changing 45. See, 45 is not a perfect square number. So if you don't have a perfect square number, you want to rewrite it with multiplication so you could get a perfect square number. So you want this to be a perfect square number so you could actually do it. The square root of 9 is 3. That's where the 3 came from. The 2 comes down. The square root of 5 can't do anything with it. Bring it down. 2 times 3 is 6. Square root of 5 comes down. Number 4. What's the trick here? What do I do? See, I recommend this, guys. Whenever you have numbers and variables and all this other stuff in there, I say split the root. Split the root to all the different terms. So like right here, it's really 25 times b to the 4th times c to the 8th. Split it up. Make it a square root of 25. Make it a square root of b to the 4th. And make it a square root of c to the 8th. So what's the square root of 25? What's the square root of b to the 4th? Remember, it's kind of like dividing by 2. So b to the 2nd. And what's the square root of c to the 8th?
4.
That's c to the 4th. And there's your answer. Ta-da. So I always recommend, guys, whenever you have a bunch of, like, it's not just a 25. It's a 25 with the ABC or with the XYZ. You have a bunch of variables in here. Even if it's one variable, split it up, right? So, like, let's say you just had a one variable, like, let's say the square root of 9x to the 5th, yeah? Square root of 9x to the 5th. What are you going to do there? What's the first thing to do? Split it up. Split it up. Like, show your work. The square root of 9 and the square root of x to the 5th. What's the square root of 9? 3. Square root of x to the 5th. I know I want it to be divisible by 2. Yeah, 2.5. But the 5, I would rather you rewrite the x to the 5th. Rewrite it as x to the 4th times x to the 1. That's using rule 1 of exponents backwards. That way, when you split them, you'll be able to do the x to the 4th. So the 3's out in the front. The square root of x to the 4th is right here, and the square root of x is right there. Again, the square root of x to the 4th, what's that? X squared, no more square root. Bring down the 3, you have the square root of x at the end. So whenever you have square root with a number and variables, please split that square root to each of the terms. If there's 3, like 9xyz, put it on the 9, put it on the x, put it on the y, put it on the z. That way you look at it in parts as opposed to the whole thing. Okay, so today's lesson is going to be about simplifying radical expressions, square roots, but with the prime factorization method or the factor tree. Check it out. The first method, which I really truly prefer, I prefer the first method. Okay, the first method is rewriting with multiplication to get a perfect square number. Okay, that's what I like. That's what I do. So I always, when I'm asked to simplify, I always think of my perfect square number list. And I know this is not a perfect square number. It's not up there. 32 is not up there. 36 is up there. So if I don't have a perfect square number,
4 times 8.
I rewrite this number with multiplication so I could get a perfect square number. So 4 times 8 works great, but there's something that works better. Remember, go for the highest perfect square number. Will 9 times something give you 32? No. Will 16 times something give you 32? Yes. 16 times 2. So if you go 16 times 2, then you could split the root. So you're going to have the square root of 16 times the square root of 2. And of course, the square root of 16 is 4, and the square root of 2, it just comes down. And that's your answer, right? That's what I've taught you. That's what we've been practicing all week. Now, some of us kind of struggle. Like, okay, 4 works, but 9, 6, 16 times. Some of us struggle with the multiplication of these big numbers. If you don't want to think about multiplying to get perfect square numbers, there's this alternate method. We're going to do a factor tree on whatever number is here, okay? So 32 What times what is 32? It doesn't matter. It doesn't have to be 16 times 2. What times what is 32?
8 times 4.
8 times 4. So if you do a factor tree, 32 becomes 8 times 4. Now break down each of the other ones. What's 8 become? 4 times 2. Okay, so the 4 breaks down to 2 times 2, and this 4 breaks down to 2 times 2. Whew. So what we really have is 1, 2, 3, 4, 5 2s. And here's the fun part. What you could do, what you could do is write your square root, and whatever pairs up, you write it one single time on the outside. So check this out. This 2 and that 2, you write it one single time on the outside. And then this 2 and this 2, you write it one single time out there, and you're going to multiply them. And that one single 2 that's left over, you leave it inside the radical. So if you look at that answer now, it's really 2 times 2, which is 4 square root of 2. It's the same answer done a different way.
Done harder.
I mean, if you're totally stuck and you're not good at multiplying bigger numbers, this might be the better option for you. Let's do a couple more. Check it out, the square root of 20. For me, I would think of the perfect square number list. And 20, I'm going to rewrite it to be what?
4 times 5.
4 times 5. If you're good at this, use it. Okay? So the final answer is going to be what? 2 square root of 5. But if you don't like that method of thinking of perfect square numbers, you could just break it down to however you want. 20 could be 2 times 10. 10 could be 2 times 5. So what paired up? The 2's paired up, so you write the 2 one single time on the outside of the root. What's left over? The 5's left over on the inside of the root. So you get the same answer, just done a different way. It's totally up to you. Now, if you are comfortable with the first way, keep it. But if you're still like, I have no idea, I don't want to think about perfect square numbers, this might be the better option for you. Let's do a couple more. So right here, you want to 48. What could we rewrite that to? I mean, 4 times 12 will work, but try a bigger perfect square number. 16 times 3. So 16 times 3, and you're going to split the root. That's square root of 16, square root of 3. Square root of 16 is 4, and the square root of 3 comes down. Now let's do it with the factor tree method. Okay. 48 breaks down to, somebody said 4 times 12. The 4 breaks down to 2 times 2. The 12 breaks down to 2 times 6. The 6 breaks down to 2 times 3. So let's, there's nothing else to break down. Let's see what paired up. There's 2 2's right here, so I'm going to put 1 2 out here. There's another 2 2's right there, so I put another 2 out there. And this 3 is left over. It doesn't pair up, so that stays on the inside, which means that my answer is 4 square root of 3. Same answer, done a different way. Okay. Okay, so on this one, we're just going to skip it. Let's go to something more interesting. I want to show you how the factor tree doesn't always work that great. Actually, let's skip this class opener. On our homework, you guys are going to be doing this in a little while. So
Let's do the 40.
check this out. Number 5. It would kind of be pointless to do the factor tree. You can't really use the factor tree. Right here, you have to use the first key concept that we learned in class, that the square root of a times the square root of b could be written together as a square root of a times b. Normally we write it backwards, but right here we want to use it backwards. So we want to put these together underneath one square root, right? You see, you can't break down the square root of 2. You can't break down the square root of 10. So let's put it together and write it as what? The square root of 20. Square root of 20. So now we could rewrite it with multiplication to get a perfect square number. You're not going to use 2 and 10. I would go with 4 times 5. That way when you split the root, you'll get 2 square root of 5. So the factor tree doesn't really help you here, right? But there are other ways of doing it. What do I mean by that? Like if I wanted to, I could rewrite the square root of 10. I could rewrite it as the square root of 2 times 5, like that, and then split the root, square root of 2 times square root of 5, And let's not forget about this outside square root of 2. Bring that down, square root of 2 right there. And why would I do that if none of these are perfect square numbers? I would do that because this outside 2 is the same as that one. It's not an outside 2, it's a square root of 2. So the square root of 2 times the square root of 2 is what?
2.
Just 2. So you really have 2 square root of 5. So that's another way of doing it as opposed to this one. Okay? So the factor tree doesn't work out that great on this question right here. So we have our homework, 10.2 WSPM, and we have a lot of them with just numbers, and we have some of them with numbers and variables. So like number 4 that just has a number, it's 99 is not a perfect square number. So I'm going to rewrite that with multiplication to get a perfect square number. What perfect square number am I going to get? Or am I going to use?
9.
9 is a perfect square number times 11. And that way, when you rewrite it, you split the root. You're going to have the square root of 9 times the square root of 11. The whole purpose of rewriting this to get a perfect square number is so you could actually take the square root of that perfect square number. So what is the square root of 9?
3.
So you have 3 square root of 11. And that is your final answer for number 4. Now, let's go to one of these guys. Right here, you could multiply the numbers with the numbers and the radicals with the radicals. So if you wanted to, you could multiply 2 and 3 and get 6, and multiply 3 and 15 and get 45, but inside the root. And then you could work on simplifying the square root of 45. 45 becomes 9 times 5. 9 is a perfect square number, so you are good. You have the outside 6 that comes down. You have the square root of 9, which is 3. And you have the square root of 5, which stays a square root of 5. So your final answer is 18, square root of 5. You guys want to see a different way of doing it?
No.
Really?
We're good.
All right. That's fine. That's fine.
Still recording?
I'm still recording, yeah. How about
Yes, that one.
this is the most entertaining one right here?
No, the 40.
You sure this one's more entertaining?
Send me all those things.
Listen up, guys. Whenever you have a number with variables, inside the radical, I would like you to split that radical to each and every one of them. So this really does say 75 times m to the 5th times p to the 2nd. Now let's split it all up. The square root of 75, the square root of m to the 5th, and the square root of p to the 2nd. So that's kind of like 3 problems in one. Which one's the easiest one to do out of those 3?
2.
P to the 2nd. What is p to the 2nd?
Second.
That's just p.
Wait.
P to 1.
If you don't remember this, let's go up here. The square root is really the power of 1/2. Hopefully you remember that. That way, when you have p to the 2nd to the 1/2 instead of the square root, you'll know that a power to a power you multiply. In other words, you're simply taking that 2 and dividing by 2, which is a 1. So that's why the answer is just p. Now, which one would you like to do next? The 75 or the m to the 5th? 75. Okay, 75 is not a perfect square number. You want to rewrite it with multiplication to get a perfect square number. So there's 3 quarters and 75 cents. So that's really 25 times 3. So you split the root now that you could actually do the square root of 25, and you'll get 5 square root of 3. Now, for the square root of m to the 5th, I would like this to be an even number, but it's not an even number. It's odd. So what I'm going to do is I'm going to rewrite it as m to the 4th times m. Okay, m to the 4th times m. That way, when I split the root, I could easily do the square root of m to the 4th. What is the square root of m to the 4th?
2.
M to the 2nd. Now, how about the square root of m? You still have it there, the square root of m. So this is your answer. It's just all unorganized. You want to put your number and then your letters, and then at the very end, your radicals, and you might as well put the radicals together. So let's go with the number 5 first, and then I have the m, and then the p, the m squared, and then the p. And then I'm going to put my radical of 3, and I'm going to put the m also in there. So that's my final answer right there. 5m squared, p square root of 3m. You don't even need the times because 3m means 3 times m. So that's your final answer right there. Number 20. I recommend always trying to simplify the inside first, but we can't simplify the inside, so we need to move on to splitting that root. Square root of 45 over the square root of 4m to the fourth. So you really have two problems here. Let's do the numerator, the square root of 45, right here on the side. What does that break down to? 9 times 5, and of course you could split the root, so you get 3 square root of 5, and that is the same thing as the square root of 45. So I'm going to write 3 square root of 5 in place of the square root of 45. Now the other one, it's like a separate problem, the square root of 4m to the fourth. You're going to split the root. You're going to split the root to each of the terms. So the square root of 4 and the square root of m to the fourth. What is the square root of 4? 2. What's the square root of m to the fourth?
2.
M to the second. So instead of the square root of 4m to the fourth, I'm going to write 2m squared. And ladies and gentlemen, we are done. It's 3 square root of 5 over 2m squared. If you need if you need more help on this homework, get on Edmodo and watch the other videos. I have a video explaining every single question on this homework assignment.